All right, so I've collected four fractions. I've collected several fractions. And all of those fractions were collected by washing my column with the sodium phosphate buffer with no sodium chloride in it. After that second fraction, I see that the A280 is effectively 0. And that, to me, is an indication, that's an early data point that I don't have any protein in those fractions. So that's my first buffer. That was my initial lysis or wash buffer, the buffer that was used to break open the tissue in the get-go. Now, after that, what I'm going to do is I'm going to use one of these 5 different buffers right here. These 5 different buffers are all sodium phosphate buffers. So they're essentially identical to the buffers that we previously used. The only difference is there is sodium chloride in there. 0.01 molar sodium chloride, 0.02 molar sodium chloride, 0.05 molar sodium chloride, 0.1 molar sodium chloride, and finally, last but not least, 0.5 molar sodium chloride. So what I'm going to be doing is I'm going to be washing my column with first the 0.01 molar sodium chloride. I'm expecting that there are some proteins that adhere to my column, but as soon as I introduce some 0.01 molar sodium chloride, those proteins will detach from that column. So I'm going to be, again, collecting fractions with my test tubes, collecting 4 fractions at a time, then reading my A280. Let's say that I collect 4 fractions and they all say, these are all 4 fractions with my 0.01 molar NaCl. They all say that there's protein in there. What should I do? Well, I should collect 4 more fractions. Let's say those first 3 of those next 4 fractions come off and they have an absorbance that indicates there's some protein in there, okay? But the last one says that there's no protein. I get an A280 of 0.01 or something like that. Well, then I'm going to move on to my next buffer with slightly more sodium chloride. You're going to be using each one of these buffers, and each one of these buffers has an increasing ionic strength. So we're going to be using a buffer until all of the ionic strength in that has eluded some proteins. Then I'll move on to a slightly stronger buffer. Once that one has been completely used, I'm going to move on to an even stronger buffer. Once that's been completely used, I'll move on to an even stronger buffer. And then finally, my last buffer is this 0.5 molar NaCl. The idea is that some proteins will elute with these different increasing ionic strengths. And our last buffer, the 0.1 molar sodium chloride buffer, is the strongest buffer that we use, so anything that's left on the column will be washed away with this. You're going to be collecting fractions and saving fractions until you have an A280 of 0. As soon as you're done with this very last buffer, this 0.5 molar NaCl, you're done and you can proceed, you can move on. What we'll do as a follow-up to this is for all of the samples where we got A5 or A280s, we're going to measure A280s. Then we're going to filter those down and say, okay, we're going to evaluate some of these to determine whether or not there's lactate dehydrogenase in there. All right, well, I hope this was helpful and I hope you have a good one.